So I was doing this limit right here, and in order to calculate it, I assumed that this is a function since it looks like a lot more like a derivative definition. If you let this be the function, f of 1 is 2 to the n, since when you replace this with 1, that becomes 2, and 2 times itself n times is 2 to the n, obviously. So this limit becomes the limit as x approaches 1 of f of x minus f of 1 over x minus 1, which is f prime of 1. Now here's the problem. What in the world is the derivative of this function? See, you usually use the product of two functions, but of n functions, that's something that I've never used before. I've probably seen before, but not specifically witnessed. So I'm taking this to another level. How about like a function like in general, okay? So how am I going to do this? So you can't do this with logarithmic derivatives, which is incredibly easy. Like you can get it in like 5 lines or something. But I'm going to do it with recursion or induction, I guess. I'm not pretty sure what the English name is that of induction of recurrence is. But anyway, I bet you get the idea. So now we'll take a look at, for example, the product rule for 3 terms. Like let's just say f, j, and h prime. So we'll use the product rule for 2 functions, then expand it, okay? So it's going to be f prime times g times h, or no need for the parentheses, that's redundant, plus f times g times h prime. Now this, we're going to use the product rule for 2 functions. So f prime times g times h plus f times g prime times h plus g times h prime. When you distribute this, you get f prime times g times h plus f times g prime times h plus f times g times h prime. Well, if you do this to like 4 and 5 functions, you're going to get something similar where there is like as many functions there's going to be as many terms. And in each term, a function is differentiated respectively, like f, g, and h. If you get like f, g times h times k, you get like in the first term f, in the second term g, in the second term h, and in the fourth term not existent, it's going to be k prime. So it looks like the derivative of that function is, if you take its derivative, it's like if it's like this in this form, it's going to be like f1 prime times f2 times f3 all the way to n plus f1 times f2 prime all the way to fn. And repeat that or go with that order until you get to like f1 times f2 all the way to f prime n. Right? So how do we prove this by induction? So I'm going to reformulate this function a little bit in this manner. So this is, I can write this as a sum, sure. So, and this sum is going to be k goes from 1 all the way to n of f prime of k of x over fk of x, right? So let this be the derivative, but I'm not finished. Okay, hold on, let me move this a little bit. No. Also move the screen a little bit towards this. So when you do this, you'll kind of get f prime of 1 or f1 prime over f1 plus f2 prime over f2, but you have to multiply by all these, right? So you're going to have to multiply by the product as k goes from 1 all the way up to n of f sub k of f, or let's just change the index in here and make it I, for example, of f sub I of x. So what happens is that, to make it clear, I'm going to just develop this. So for example, for the first term, it's going to be f1, and that's times the sum. That's, for example, going to be f1. Hold on. That's going to be f1 times f2 times f3 all the way to fn. And that's multiplied by f prime by f1 prime over f2 plus f2 prime over f2 this is f1. Sorry. fn prime over fn. So when you multiply this, you're going to get, of course, n terms. And when you, so each term by term, right? Because there's a sum in here. So the f1 is going to cancel out with the f1, and we're going to get this one. The f2 is going to cancel out with the f2, and we're going to get like this one. And then the f3 is we're going to be with the f3 in here, and we're going to get the other one. And the fn is going to cancel out with the fn in here, and we're going to get this one. So this is the same form. And we'll need to prove that this is the derivative of the function above, right? So how would you do that? So we verified for like 2 functions. You can do that. I'm not doing that in here. So I'm going straight. So let n be a natural integer. Let's just say a non-zero value. So suppose that if f of x, suppose that, okay, I'm just gonna put the logical formula, f of x equal to the product as I goes from 1 all the way to n of f sub I of x. That means that the derivative is, notice that this is exactly this, which means it's f of x times the sum of those derivatives, of those logarithmic derivatives, equals to 1 all the way to n of f sub k of x prime over f sub k of x. So we're supposing that this is true. In order to make the induction, we need to prove that for f of x going from 1 all the way to n plus 1 of f sub I of x, that means that the derivative, so we have to like add an n everywhere there's an n, I guess, is going to be this f of x times the sum as k goes from 1 all the way to n plus 1 of f sub k prime over f sub k of x. So how do you do that? So for this f of x, we're having this term. So this n plus 1 term, that means that we're multiplying by f sub n plus 1. We're adding another term. We're multiplying by another term. So we're going to get that outside and get the function above. So f sub n plus 1 of x times the product as I goes from 1 all the way to n of f sub I of x. Of f sub I of x. Now what? Now we're going to do the product rule, since we know the derivative of this, or we suppose that the derivative of this is this. So we're going to do that. And that's going to be, so it's going to be f sub n plus 1 prime times this product. I goes from 1 to n of f sub I of x plus f sub n plus 1 of x times the derivative of that product. It's going to be I going from 1 all the way to n of f sub I of x. Now for this, we have the formula already. You can go back to see it. I already memorized it. F sub n, okay, f sub n plus 1 prime times this product, I is equal to 1 times n, f sub I of x, plus f sub n plus 1. Hold on, let me just zoom out a little bit to make room for my work. And the derivative, yeah, it's f of it's this product right here, I is equal to 1 all the way to n, f sub I of x times the sum as k goes from 1 all the way to n of f sub k prime of x over f sub k. I'm sorry that my k's look like x's, so Yeah, now here we have this mess, right? We have to turn it into this thing somehow. But if you notice, if you divide and multiply by the last term or the extra term, the n+1 term, you can make this into the n+1 product. So we're going to just do that. And also, you notice that this can be merged with this product. So this becomes an n+1, so we can factorize that. So we can get f of x. So, actually, oh my god, I'm terribly sorry I didn't add the prime in there. F prime is equal to f prime sub n, f sub n+1 prime over f sub n+1 of x. And this becomes the product to n+1 of f sub I of x. Plus, and this becomes the product as I goes from 1 all the way to n+1 of f sub I of x, times the sum as k goes from 1. What in the world is that? K goes from 1 all the way to n of f sub k prime over f sub k. This is f of x, we can factorize with it, and this becomes f prime of x, f of x times this f prime f sub n+1 prime of x over f sub n+1 of x, plus the sum, k goes from 1 all the way to n, of f sub k of x prime over f sub k of x. This is the extra term of this, so we can merge them together again, and this becomes f prime of x is equal to f of x times the sum as k goes from 1 all the way to n of f sub k prime of x over f sub k of x. And this is exactly the formula that we were looking for in here. Which means that we proved the formula by induction. Which means that for all n in non-zero, that means for all n that are non-zero integers, f of x, if f of x is the product of n functions, that means that f prime of x is the original function times this sum of logarithmic derivatives, as k goes from 1 all the way to n of f sub k of x prime over f sub k of x. Cool. Now we can do the limit, I guess, that we were dealing with above, which was the original problem. Now this becomes a piece of cake, so which means that this is f of x. We need to find f prime of x. We know that f prime of x is going to be f of x times sum as k goes from 1 all the way to, like, or let's just use I in here since we used k before. I goes from 1 all the way to n of the derivative of this, which is k times x to the k minus 1 over x to the k plus 1. Now, in order to calculate the limit, this L limit is equal to that limit, of course, which is f prime of 1, which is equal to f of 1 times the sum. Now, focus with me, of course. This substitute with 1 gives you 1, and this is a 2, so which becomes k times 1/2. This is 2 to the n, which becomes 2 to the n, and with this 1/2 in here, it becomes 2 to the n minus 1. And this is the sum as I goes from 1 all the way to n of k, which, of course, becomes 2 to the n minus 1 times n plus 1 over 2. Remember to memorize your summation formulas. And this 1/2 in here merges with the 2 to the n minus 1 to become 2 to the n minus 2 times n plus 1. So that's the limit right there. Thank you for watching.